Yeah, this was the talk that I was supposed to give at ETH Denver. That ironically, I did not. I did not actually give at ETH Denver because I mean I gave a very similar talk at ETH Denver. I had the most horrible technical failures that I've ever had attempting to give a talk. I managed to fail to get internet to the right devices. They tried to provide me internet by USB-C. I borrowed a laptop from somebody in the audience. Absolutely nothing succeeded in working. And in the end, after using half my time just trying to get the tech to work, I just stood up in front of people and just gave a talk. But I couldn't actually explain the issue because I do have slides for that. So, and actually, what's really good is that I gave the bag of hacks talk to this class. Actually, it's this. I'm clipping. Uh, oh, it's not. It's not there. Either of those change the input. Well, that'll work. I gave the bag of hacks talk to this class, and this is almost in some sense a patch to that talk. So okay, I mean, I've got a slide of me. You all know who I am, but gray hat hacker and local politician in California, known for Cydia and for working at Orchid. Here's then the connection to that prior talk that I'd given all of you. So I give a lot of talks on the kinds of issues that we see in software, whether they be I use extra free bugs that I almost think get too much play because they are something that is largely preventable using different programming languages, and I think blinds people to the number of logic bugs that you can experience by making mistakes, whether it be layer handling, parser differentials, boundary conditions, native type aliasing, all these issues that we talked about in that previous talk. So I ended up writing. I did a write up on this, and it's a very long and extensive write up. So if you want to look at this later, it's www.sorted.com/optimism.html. I do have a slightly different point that I'm making though. So what is optimism? The dictionary defines optimism. Webster's dictionary defines optimism as a doctrine that this world is the best possible world, an inclination to put forward the most favorable construction upon actions and events or to anticipate the best possible outcome. Now, optimism, as we use it in the Ethereum community, is a project that builds a layer 2 optimistic rollup on top of Ethereum. And so all of the data for all the transactions is committed to Ethereum, but the actual logic to implement it happens over on the side. So that way, people who don't want to execute, like all the people who are normally running Ethereum, don't have to run all of the code for Optimism. They're just maintaining the storage layer that Optimism happens to use. And then Optimism separately only has to run the transactions that actually relate to Optimism. So this optimistic rollup, the Optimism part, comes from when you want to make when something happens on the L2 and you want that change to be like on the layer that's the L2 being the layer that's sitting on top of Ethereum. When you want that change to be noticed by the layer one, by Ethereum itself, you have to essentially prove to Ethereum that the layer two did something because the Ethereum isn't running Optimism. It's all it knows is all the data for Optimism, and so optimistic rollups kind of assume that everyone's acting okay, and then they if somebody acts in bad faith, you can kind of go back through and attempt to prove that the party did something wrong. So the mistake that they've really made, which actually is not, this explanation I just provided is kind of more detailed for you all. I mean, I wouldn't have gone into much detail, I think, even in that was really just kind of a throwaway joke almost, for instance, for the ETH Denver audience. But so this doesn't connect exactly, but this is related. So if the Ether exists on the layer one on Ethereum, and then when you want to use Ether on the L2, um, you you have to lock up the Ether and contract on the L1. By the way, I'm realizing that I've managed to make a little like hot box here with the lighting and everything, and it was already hot before, and so I'm just like melting. Okay. um, the you have to lock up the money on Ethereum, and then that allow, and then you can. It's easy for Ethereum to show to the order of operations to show to Optimism when the money appears in Optimism. Proving in the other direction is the whole optimistic rollup part. What they did, so they essentially built a new Ethereum-like construct on top of Ethereum. And when I went to read the documentation, this is actually tech from them, from their website at the time. We do not have built-in native Ether support. For example, this means you will not be allowed to use balance or self-balance. I'm like, well, what does that mean? And so when you lock up the Ether on the L1 on Ethereum, it appears on the L2 as an ERC20 contract. ERC20 is a standard that defines a fungible token that you can trade around. And so rather than on Optimism, rather than money looking like money, it kind of looks like a data in a program, which they thought was kind of cool. They were like, this allows projects to not have to write their contracts to support both of these things. They can just support ERC20. But it was actually really frustrating for me because I've a lot of contracts that, whether I have ones that I've written or ones that I'm interested in, they assume the existence of that money layer. And it seemed really frustrating that they kind of removed it. So they offered, if this type of functionality is critical for application, please let us know on Discord. And I actually showed up. This is December 6th of 2000 and October 6th of 2020. And I was like, this is actually a problem. You're not really compatible with Ethereum. To be clear, this I was kind of explaining to them, this isn't entitled demand to do anything, as I'm just only mentioning as you asked me on your website. I absolutely use these instructions in semantics and don't really consider your chain compliant if it doesn't fully support them fully. And I'm certainly not going to adjust my contracts to one-off run on this platform for numerous reasons. And then kind of explaining that if you want to build a layer on top of a layer one that goes to this much trouble to replicate the semantics and behavior of the underlying layer, you should not just arbitrarily draw this key property of the data model. Now, it took them about a year to realize that I was right. I mean, not, they weren't sitting there going like Sork was right, but they came to the same conclusion that I had been trying to tell them a year earlier. And they ended up coming out with OVM 2.0, which they started talking about as being EVM equivalent instead of merely what they called EVM compatible. I'm like, it wasn't compliant before. It's EVM compliant. Before it was just a non-compliant EVM-like construct. But they didn't get rid of that ERC20 contract. So when you took money from the L1, from Ethereum, and you locked it up and it appeared on the L2, it would appear inside of this ERC20 contract, and then you would work with it there. They then took the instructions that you use for accessing the normal kind of money, like the money that your account has, and they weirdly mapped it into the data structure of that contract. And they did it by adding a bunch of if statements throughout the code. So there's a function set balance, and they added this flag using OVM, which is using the optimistic virtual machine, their system. And if you're using OVM, then you do different behavior. So the original behavior was it would get the state object and it would call set balance on it. But no. If you're using OVM, what you're instead going to do is you're going to go into the OVM ETH address, which is the ERC20 contract, and you're going to set state inside of that contract in order to change the balance inside of it. Now, already, by the way, I'm going to point out this is kind of wrong. This is already semantically problematic because there's an observable side effect to get or new state object. If there is not a state object, one is created. And there are ways within contracts where you can tell the difference between an object, like an account that has a state object and ones that don't. And so this code is already they didn't really get this right in some sense. They're just kind of trying to map some of the semantics, and they've kind of failed to map everything. They then, then there's a key thing. This is actually where the bug really was, is that there is a instruction it's now called self-destruct. It had previously been called suicide. There are many reasons why that name is not a very good name to be using in these contexts, but the code for Optimism still calls it suicide. So that's why I've got all this naming in here. It has here's the function for op suicide, which is the instruction in the EVM, in the OVM, that is running that instruction. And when a contract self-destructs, it has the opportunity to take the money that it owns, the normal money, like the layer one-ish kind of money that it would have had, like the deep, not the ERC20 contract, but normal money, and send that money to a beneficiary. And that beneficiary is argument that's passed on the stack to this instruction. And so what the code is doing here is it gets the balance of the contract that's destructing, and then it gives that balance, it adds that balance to the beneficiary, and then it destroys the current contract, state.suicide contract inverse. The implementation of state.suicide is that it gets the state object, it marks it as suicided, which awkwardly just sets a Boolean. So the question then becomes, when does it actually go away? And it turns out that doesn't happen until the end of the transaction. And then it clears its balance. And it does that by doing state object dot data dot balance is equal to new big int. Now, this code bothers me for a few reasons. One of which is that it should be using state object dot set balance. There's already an accessor on that. Instead, what it's doing is it's reaching its reaching its grubby mitts right into the state object in order to pull out the private field data, which is package private. It's something that is accessible in this code because all of the state object private fields are accessible from the state database. So it's reaching into the state object's private field, getting data, and then, which is for people who don't read Go, all lowercase lettered variables are, all lowercase lettered fields are package private, to use like a Java term. And then it's using the private field of the data part, but that's it's already got the private thing balance in order to set it to a new big int. And so there's a constant. Kind of bothered me that they didn't use this constant. So the code I would have wanted to see there is state object dot set balance common dot big 0. But the real problem here, let's verify that the real problem here is that the OVM people didn't change this code. So when they went through and they changed things like set balance, so people don't read Go, this is a method on the state database, not on the state object. Suicide is a method on the state database, not on the state object. So suicide is at the same level as set balance, which means that if you're modifying set if statements, you have to add those if statements to suicide also. And so the fix is that you have to you would have to right here add an if statement if using OVM. Instead of doing .data.balance is equal to 0, you would have to do the get OVM balance key big to hash OVM ETH address and set that state field to 0. So they weren't actually deleting the balance that the contract had. So the behavior of op suicide then was that it would take the current contract's balance, hand it to a third party by increasing their balance. So now both parties have the balance. And then it would clear this data.balance field, which is not used in the OVM, which would mean that at the end of this function, both parties have all of the money. And then, because this object is marked suicided, it actually lives on till the end of the transaction. And so you can continue to interact with this address that owns all of the money that it already gave to somebody else until the end of the contract, until the end of the transaction. The fix that they ended up putting into this is almost more awkward than what I described. So first of all, they kind of had to continue supporting the old behavior for up until the point of the change, and then they support the new behavior. So they've had to get another if statement. We get another if conditional here on this op mainnet self-destruct fork num, which is the block number at which they fixed the behavior. And they went into not the suicide method on the state database, but into suicide. All the way back, like up and up. We're not even in the state database anymore. And they added the if statement here. And they said, if using OVM and is self-destruct inflation, which is this self-destruct fork num, then they subtract the balance. So now the behavior is that the contract has all the money and the beneficiary has none of it. The beneficiary is given the money. And then the money is removed from the contract. This behavior is still wrong. They have the running trope from my bag of hacks talks about you fix bugs and you just keep making the problem worse almost. So the behavior now is that before whose bug is arguably the behavior before was dumb, but like the behavior before is what the spec says. So let's say that I've got all the money and I'm the contract, and then I self-destruct and I send all the money to myself. So the old behavior, if you had like 2 ETH, you would now take 2 ETH, give yourself 2 ETH, so you have 4 ETH, and then you'd self-destruct and you would have 0 ETH. But now, according to this new implementation, you would have 2 ETH, you'd give yourself 2 ETH, and then you subtract 2 ETH, and so you'd be left with 2 ETH. Arguably, the new behavior is better. Like, money isn't just arbitrarily destroyed. It was kind of weird that there was a way to not just hand money to somebody that couldn't access it, like give it to the zero address or something, but to actually like destroy money so it didn't exist in the system anymore. But that's what it did, and now the behavior is still non-compliant and incorrect. And they also had to add this if statement, I will claim, and I'm pretty sure actually, they added this if statement in the op suicide because they needed to get access to this interpreter.evm.chain config, and a state database doesn't have an interpreter. The virtual machine has an interpreter. So in order to determine this new fork number point and what block you're currently executing at, they had to not do this change in the state database, which I'm going to point out is even messier code. So now what they've done is they've taken these if statements that they've riddled throughout the state database. And now they've got one of these if statements up in the virtual machine also. My claim here, kind of like the core problem that they're causing, is that this is a cross-cutting concern. So sometimes I give talks on like affect-oriented development and all the work on like substrate and runtime code modification in the iOS community and everything. And what they've done in the code is they've said that there's this new behavior, which is that anytime we were managing balances, we want to instead manage state in an ERC20 contract. So in a perfect world, you might specify some kind of query where you would say, I'm going to find all the code that has a certain kind of set of behaviors, and I want to change it to work in a new way. And well, that's in one perfect world.
Okay.
In another, yeah.
Oh, there we go. Sorry, Murat had a question and we were trying to talk, but it wasn't.
Oh yeah, I knew you were on mute or something. Hello, yeah.
This last lecture, we talked a little bit about JMonitor and about aspect-oriented. So this is actually, you touched on a couple of things. This is very cool. So can you take this from the top again?
The cross-cutting concerns? Yeah. So I look at this. What they did is they added this if statement that used to be they just had if statements in the state database. And now they've got if statements like here in the state database. And now they've added an if statement up in the virtual machine also. And all of these if statements are trying to modify a particular kind of behavior in the code where they're taking anything that would have modified the balance, and they're modifying it so that instead of modifying the balance, it is now modifying the state in this ERC20 contract. And so there are a couple ways you can go about this. One way is kind of an object-oriented concern sort of way, where if you had a query that you could perform, where you could say, find me all of the code that modifies the balance, change it so that it instead modifies this other external state. That would be one clean way of doing it, and that's the kind of change that I've sometimes been able to pull off in like Substrate, and sometimes when you see some of the work in aspect-oriented programming or in JMonitor, being able to specify like when certain fields get changed, like on change of the balance field in a state database, so in a state object data field, you would then want to kind of walk back up in order to get access to the state database and then query down. And you could actually specify this behavior somewhat cleanly in a single location. And that way you'd have the original code written by the Ethereum people that you kind of trust, and then you'd have the change that you made over on the side. Another way of looking at this, which I think is a very reasonable way of doing this, is to find the bottleneck. So you want to find somewhere in the code that you can cleanly state the intention of the change occurs at this point. And I will claim that the correct place to do that is not in the state database. The state database has a bunch of functions like add balance. I've been showing it, but like they've got other functions like add balance. Add balance gets the state object and then calls state object.getBalance, adds the value to it, and then calls state object.setBalance. So all of the various accessors that work from the state database are all reaching into the state object and are modifying the state. The state object is where the bottleneck is. Why is the state database even being implicated in this? And so I would have said that like the clean way of doing this, like somebody who is sitting down and thinking carefully about the problem of how in Go, where I don't have, aspect-oriented programming like, join points and point cuts and the ability to try to do all these things. Where would I make that change? The change would be in two functions only, in state objects, get balance, and state objects, set balance. And if you make the change in those two places to redirect the behavior somewhere else, and it might be weird because the state object doesn't, maybe this is why the state objects don't have access to the ERC20 contract. Well, you'd have to give it access to the ERC20 contract. But that would be cleaner and safer because you wouldn't have to like play whack-a-mole with all the different places. The sad part, though, and I touched on this, is that the code in state database suicide was wrong anyway. Like, wrong. It was correct. Like the behavior's correct. If you build unit tests for this and the behavior's correct, but the semantics of it are totally wrong. It should not be state object.data.balance. It should be state object.set balance, because the goal of having that set balance setter function is to bottleneck all attempts to using that field architecturally into calling that function, such that if at some later point in time somebody decides to, and they did, make a really weird change that, I imagine when you're building something like this, you're like, who would ever not have that field there? Well, apparently somebody thought it'd be really cool to make all of the fields actually get stored in a external ERC20 contract storage state. You can do that change in one place. So the Go Ethereum, the original developers, I feel, left a time bomb, a ticking time bomb in their code here, where even if you had done this the careful thinking way of where's the bottleneck, they'll set it, you still would have gotten it wrong. So now the question I will ask is, why did the Go Ethereum developers get this wrong? And I'm going to claim that it's due to a weird semantic of Go. So stateObject.data is something that if you were in Java, I don't think you would ever have typed. The reason why is because the Java developer would have marked data as being probably private, maybe protected. State object in the state database wouldn't have access to that field, and so you wouldn't even be able to access it anyway. And they would have then exposed the accessor, and they would have forced everyone to go to the accessor, which would have made the refactoring process later of making changes to the code make sense. There is a feature, however, in Java called package package level access, where you can specify that something is public, in which case anyone has access to the field. Protected, only subclasses have access to the field. Private, only the current classes have access to the field. Or you could just not mark it with anything at all. And if you don't put anything on it, then it's by default. Anyone within the same package that you're in has access to that field. And my memory of spending a lot of time working in Java a while back is that was kind of like not okay. Like there were use cases for that, but you would never just do that. That would be a massive code smell that you're using the package local access. And you should be thinking through the access control of it. You should either think of it as a value struct and making it a public field, or you should mark it as private. And then you can imagine what you would do in the case of trying to make this refactor. If somebody had thought of it as a value field, is you would first mark it private, you'd make the accessor, you would then find compile errors everywhere else in the code where they were using the diff field directly. You would change them to use the accessor. In a refactoring IDE such as Eclipse, you could probably just right-click the field and say change to accessor, and would change all your code at once like that. And then you would be able to modify the accessor. But I feel like we've actually lost something, and this is my weirdly contrarian opinion that I feel comfortable giving it. Even I was even going to give a talk at Denver and talk about it, although I ended up not be able to get into this. But I would not write in an article trying to really defend it, because I imagine just the sheer amount of argument on Hacker News. Like people are much more forgiving when you kind of like talk off the cuff and about these aspects in a talk, even if they're watching a YouTube video later, than analyzing it. I actually think that object orientation did something good, and right now it's really considered like bad. All the stuff from object oriented people programming, and people actually seem to really like the idea of I think, functionality that is directly modifying all the fields. And I think that actually there was a structural maintenance. There was like an organizational structure reason why some of those aspects of object-oriented programming work the way that they do. But regardless, let's look at the attack. The attack is relatively simple. We make a contract that this is written in this programming language called Solidity. And the contract has a function on it called destroy, which calls self-destruct and passes itself as the argument. So the money will go to itself. And so that way, if it had 2 ETH, it now has 4 ETH because it will get its balance, add it to itself. It is 4 ETH, and then balance doesn't go away. So it has 4 ETH. You can call destruct in a loop. And so you're going to go 2, 4, 8, 16. You just double the amount of money that the thing has every time. And then at the end, you can call take, and you can get the money out of the contract by having it just do a normal send of all the money to you. We then make another contract that will use that contract. This contract, because we want to do this all in a transaction to make it easy, because the contract does not go away at the end of the transaction. You could still pull this off, even if some people have been like, oh, they're really relying on that weird behavior. There's actually another set of weird behaviors that I was almost excited to use, and I was kind of sad that it was a CC. But there's you have the ability to resurrect contracts, and I could actually resurrect a contract at the address that's still delivering money. But this is really easy. We just instantiate the exploit contract, and then call destruct in a loop, doubling the money each time, take the money out of it, and then hand the money off to somebody else. And then what you can also do this all in one transaction is you just construct this contract, and you pass it some money, as they call it an endowment, I believe, when you set up a contract and you give it money when it starts. And so you give the money, this contract, that endowment. This contract then is going to, in a loop, double that money, essentially investing it in some weird scheme, right? Double that money until then it can give you all of the return at the end by calling message sender, transfer the balance. Now, this kind of bug, I think, is actually a really serious bug. So this is a photo from or a few frames from a Rick and Morty episode, where Rick is like, here's how he's going to destroy the Galactic Federation. He's going to go into the database and he's going to set the value of one of their units of currency to 0. And this is, I think, a good description of the kinds of bugs we usually see in crypto, is we see these bridge bugs. So these bridge bugs end up so the money, most of the bugs you see in crypto, where there's the money got deposited on Ethereum on the L1, and you go to take it out on the L2, and then later on you want to get the money back, and so you destroy the money on the L2, and then you can unlock it on the L1, and you can go and you can take it somewhere, and and that's where you have to prove to the L1 that the L2 destroyed the money, and that's where you get the optimistic rollups, the zero knowledge proofs, some of those things. And this also is used for cross-chain transactions, anything like that. And what typically you'll see people do is they will go to the treasury and they will just steal all the money. Where everyone locked up their money on the L1 and they steal all the money from them. And when you do that, all of the money on the L2 effectively becomes immediately worthless. It's like you went to Fort Knox back when we were on the gold standard, and everyone's dollar bill was backed by a bar of gold in Fort Knox, and you just stole all the gold. And now all the money is now all of the money is worthless. But everyone still has the money. And I think that's important to note, is that in most of these attacks, if you go and you steal all the gold from Fort Knox, you theoretically could go get more gold. Your entire country could get bailed out by another country. You could go and mine a bunch of gold quickly. There are ways you could try to fix the situation. And hopefully the unit of exchange, if you didn't even tell anybody about it, they probably wouldn't even notice for a while, and it wouldn't be bad, because it's not like there's no one who's taking advantage of the money being at the wrong value in some sense of that. And this we've seen in some of these bridge bugs. There was, on the same day that I found this, the same day that I reported this Optimism bug to the Optimism people, there was a bug that was just publicly disclosed. There was a bug that was abused. There was an attack that was made that stole hundreds of millions of dollars from a bridge between Ethereum and Solana. And the company that owned that bridge put a few $100 million more in there and just bailed out the bridge. And I think that the bug that this optimism bug is actually worse. So the optimism bug, what's going to happen is that on the other side of the bridge, on the other side from where all the reservoir of the real money is, people are going to, there's like one person who just has an infinite amount of money. And one thing that they could do is they could just start trying to withdraw the money. And that I think that would actually have a very similar effect to the bridge bugs. But instead, what I'm going to suggest that you do is you go and you just start buying stuff. You just go, like, if you actually there's another thing I should point out. A lot of the crypto community knows this, but like I should point this out to y'all. It's actually difficult to steal money. What ends up happening is if you steal all that money, as the wormhole guy did, you steal all that money from that repository, and then you want to go cash it out. You have to convince an exchange to give you fiat for it. You've got to a lot of the governance mechanisms start trying to blacklist the addresses related to that. There's actually a bunch of, by the way, semantic and philosophical issues that you can start asking, like, what does it mean in a fungible token if some of the money has been tainted by going through a black market? And we can start asking questions about how's that related to counterfeit money that goes through the real world, fiat economies, and there's all sorts of interesting things that go on there. But the reality of it is that people don't seem to actually be able to get hundreds of millions of dollars of stolen money out of the system. So instead, if you go for damage, I think that stealing the hundreds of millions of dollars does hurt somebody. But I think that you can do worse. And that's where you go and you start buying stuff. And you start buying stuff, and what's going to happen is that a bunch of the automated DeFi arbitrage systems that are trying to automatically maintain the value, all the different liquidity pools across the whole system, are going to notice there's a whale on Optimism. Somebody's got a lot of Ether, and they're buying up all the AVAX. And they're going to start transferring AVAX into Optimism in order to sell it to you, in order to get the Ether. And they might not, and I think, and even if they did start doing it, actually takes so long on Optimism because it's this optimistic thing. It takes like 7 days. But if they start trying to get the money out, like start getting the Ether out, it's not even fast enough to cause the effect. So you're just going to start causing more and more money to appear in Optimism until finally somebody might start to realize this is messed up. Somebody must have a bug or something, right? Like there's just way too much money sitting around in Optimism. There's who even know this? There's somebody who's been buying stuff that's the amount of value sitting inside of Optimism now is way higher than the amount of money that ever was transferred into Optimism. But weirdly, it takes a while to figure that out. And I can say that for sure because somebody actually triggered this bug already and no one noticed. They didn't attack it, but they just triggered it. And I think what that does is it destroys the ledger. It makes it so that you lose confidence in the existence of Optimism and all the transactions that occurred. And now, even if you sit down, you're like, I've got a few $100 million in order to try to bail the ecosystem. Now what? Who do you give the money to? Everyone has been doing. Some people have been doing legitimate transactions. A lot of people maybe haven't been. And there's now no way of determining who should or should not be compensated for the attack. And so I think you can, like, if you're trying to go for max damage and griefing, this was actually a really serious issue. The person who found the bug, by the way, it's a funny story. I traced the person down. The person who found the bug for Etherscan, which is the major block explorer platform that's used in order to see all the transactions and all the accounts. And the Optimism and the Etherscan person was clearly trying to figure out that there was like a bug in their display of the account. Like they would do the self-destruct on a contract, and then the contract would still have money in it. And I finally managed to like talk to the guy, and like reached out and talked to him, and he it didn't really occur to him to try to figure out what was really going on. He was just, there's a weird bug. Issue tracker somewhere in order to try to figure out why it was happening. Probably assumed it was a bug in Etherscan, right? But didn't follow up on it. And this was the day before Christmas. And so those transactions that had caused some money to get constructed out of nowhere had been sitting in the system for over a month. And no one noticed that money appeared out of nowhere. And I think that also is telling that the kind of bug changes how quickly it gets detected. If you go into that treasury and you steal the money, I think people actually notice it very quickly. So this mistake did cost somebody some money. There was a bug bounty I found when I was looking into how to report the bug for $2 million for any kind of number of mostly smart contract related bugs and optimism. This technically was out of scope. This is something that I actually was kind of expecting that I was going to end up with some kind of argument over the process of it. I mean, this actually seemed to me like a more serious bug than something in smart contracts in some sense. But I reached out to Optimism, and they were immediately very gracious about saying, we will pay out at the amount. And actually, it wasn't $2 million; it was $2,042. Because there was like a list on this Immunify platform of all the bounties, and they wanted it to appear at the top. It sorts by size, so they added 42 to it. The magic number 42, and they and so we actually thought for a while this might be the biggest bug bounty for a single payout to a single researcher, like a payout to a single researcher, as opposed to there was actually a bug in Polygon where there's a set of people, each of which got a bunch of money because they all found the same bug and they were gracious enough to. So it's wasn't the largest payout, but the largest reception. But then we found out that there was actually first Boba was willing to throw in because it was two. There was the largest one we found was 2 million. It seemed like that would be kind of like a technicality. Boba, which was a fork of the Optimism code, threw in another 100,000, which was their max bug bounty. They're a much smaller network, so it actually makes sense. And so now it actually felt very legitimate. This might be the largest bug bounty payout ever, but it turns out there's actually a $2.2 million one from Polygon. I will point out there's another fork of Optimism, Metis, that is as large as Optimism that did not throw anything into creating this. And whether you want the money to go to me, whether you think the money should go to Optimism, I do think there's something weird about the incentive alignment of various players when you're forking other people's code bases and relying upon their ecosystem without contributing to the security infrastructure parts of it. It's weird to me. But the point I was going to make. $2 million. Oh, I think that this is something where it's there's something that I find kind of frustrating about the crypto ecosystem as a whole in some sense, which is I feel like there's been a lot of externalization of the core design and security of a lot of the projects. And so I feel like and at least it is a large bounty at the end. The feeling that if this were $20,000 bounty or something, and you start to be there was somebody who was putting at risk about $500 million of other people's money, and they managed to make what feel like very simple security mistakes. When I show this these code slides to other security people, they just get horrified. They're these if statements. You're just there's no way you're gonna whack-a-mole all the places with these if statements. You show it to something like GeoHarmony, you're just gonna start drooling over the idea of I'm gonna find so many bugs. We'll just do a full audit of all the places where you should put the if statement. But I know there's gonna be at least one you're gonna get wrong. And I think it's depressing that in an ecosystem where everything should be about security, math, financial incentives, we oftentimes see a bunch of engineers playing it fast and loose, moving fast and breaking things and using the old Silicon Valley mantra. And even Facebook eventually came to dislike. They changed their whole thing to like that. Oh, I knew this. Yeah, they ended up changing their whole thing to move fast with stable infra. So these are the paragraphs. I kind of had at the end of my article kind of a bunch of moral, ethical thought processes. And I actually did want to read just this one section here that really resonated with people. So one of the more fun things of working in crypto is exactly what makes it scary. The monetary stakes tend to be extremely high. One ramification of this is that security research matters a lot more than other fields of software. And yet a complaint that I too often have about crypto projects is that they sometimes seem to play fast and loose with consensus or correctness, while they move fast and break things their way to access large amounts of investment capital. Meanwhile, projects that take more conservative approaches are seen to move slowly and too carefully. And as with Web 2.0 companies that spend too much time protecting user privacy before launching new features, they are at a disadvantage. I thereby sometimes balk at helping other projects with basic issues of decentralization or security, as I feel like those can't be afterthoughts. This stuff is too important to be released quickly and adjusting the design in the field. And yet we see crypto project after crypto project trying to externalize the cost of their core design to people being only indirectly compensated, rather than building a team around mathematicians, economists, and security experts. And then here's the slide. Actually, Mark Zuckerberg was asked about this. this was like a statement to Washington Post or something. Because when you build something that you don't have to fix 10 times, you can move forward on top of what you built. These are real changes that we're making so people can rely on us as critical infrastructure for building all of their apps across every mobile platform. And weirdly, even though crypto is already at the point where we're moving around billions of dollars on it, we somehow haven't transitioned to move fast with stable infra from move fast and break things. And I think that one final thing that I pointed out this class before, within I think that test-driven design is somewhat frustrating because I think that people oftentimes think, "Well, let's put together some tests. I'll make sure my tests are correct." And I mean, there were tests. I've actually got to ask various people. There are suicide tests, and some of the tests have been disabled because the typical behavior process relating to tests is that you make changes to parts of the code and some of the tests are invalid. And other tests didn't test the full set of behaviors because they were testing it like at the unit test level, like does the state object work correctly? And so they didn't catch this in any of that either. It's not how I thought it either. I have been intending to build a more complicated test suite to try to find other kinds of not consensus mistakes, but like compatibility, compliance mistakes between different chains. But I think that we need to think about measure twice, cut once. Like somebody should sit down before they release a software, just stare at it and really think, what are the ways in which this could go wrong? Have I accounted for the ways in which this could go wrong? Was the process I used to modify the code base a process that would cause me to catch all of the ways that this could go wrong? Or am I going to have likely accidentally left something in the place? And I think that that's kind of this core thing where when you sit down and you're just like, oh, I kind of want behavior to look like this, and you quickly go make the behavior look like that, you skip that part of really thinking through, how do I make the behavior get to where I want, and what is the process I want? Because you've chosen this process of just whacking it until it looks right, instead of thinking about it and deciding, okay, if I want to make an EVM 20 contract store all of the state, I need to find all the locations in the code base that modify bounds. So the process should not be just kind of thinking about that. Maybe I'll do a grep of the code. I seriously, like if I were making this, I would have caught, I'm very confident, I would have caught the get when making that change, because I would have gone through and I would have first deleted that balance field or renamed it. And that would have given me compilers across the entire code base trying to figure, and then I would audit it, wrote them all down, and then went through and made certain that I had a checklist of every single place in the code base that I had to make a change in order to be able to fix the thing. Because to me, that's the process that you have to use to make that kind of change, is you decide what kind of edit you want to make. You figure out how you will apply that edit. You then execute your strategy, and then you go back and you re-verify that your strategy made sense. And at the end, you might go back and try to check, did it work? But you don't start with, did it work, and whack at it until it works. So, any question?
Jay, you here?
I hear somebody, yes.
Yeah, it's me, Ross. Well, first of all, thank you. This is awesome. And it's also pretty, relevant to what we've been talking about recently, which is a little surprising. But one thing I want to ask you is and this goes back to the your exploit, the code you exploit. You had that, for loop where you self-destruct the thing, the object, and then you go subsequently you say take, which we just alluded to. I mean, there's something semantically off with that whole thing. Shouldn't self-destruct just destruct the thing, or mark it so it won't respond to the contract? What is the contract for self-destruct? I don't mean
so the specification for self-destruct is that and exactly where this happened, I kind of get the impression that the specifications that we have in the Ethereum ecosystem were largely written by Gavin. I'm forgetting his last name, but it was written by Gavin as a response to the code. Like you start with the code, and then people are asked, "What's the spec?" and then he like writes the spec to describe the code. And the sorry, I feel like he's I'm sorry. Yeah, remember the question was about the implementation of self-destruct. So the way it's been spec'd is that at the end of the transaction, the state object for the account will be destroyed. So at the moment of the self-destruct instruction, its balance should become 0, but its code will still exist until the end of the transaction. And the implementation in the EVM has it go and at the end of the transaction, it loops through all of the dirty state objects and checks to see which ones have been marked suicided. And then the ones that have been marked suicided are then set up for deletion, which weirdly they actually then put up until the end of the block because they don't really need to update the actual database into the block. And it might be that the next transaction affects those same objects again that got deleted. And so they have another level of putting it off. But I agree. Like the semantics you would have expected would be that the self-destruct would cause the contract to immediately disappear. The weird thing, though, is that it actually wouldn't fix the problem. So there's another instruction called create to. So there's instruction create, which creates a new contract. It's how you instantiate a contract. And create takes as its argument the constructor code for the contract, which returns the code for the contract, which has some cool benefits. And it's actually fairly similar to the semantics of some other programming languages and things where you like call a constructor function that returns a new object that's been set up and various things. But the address of the contract you create normally is a hash of the contract that or the account, which might be a person, that created the contract, and a nonce, which is incremented every time a contract creates a contract, or a user does anything. So the idea is within like Ethereum, I would never be able to create the same contract address twice because I will have had to do something to do something. So I would, if my nonce will be greater than it was the last time I created the contract, and the hash of my address and the nonce will now give me a new location. There's another instruction that was added called create to, which changes the behavior so that instead of being that hash of the creator and the nonce, it is the creator and the constructor code. And salt, which you can configure, but like that just you could imagine just concatenating that to the end of the constructor code. It's almost pointless. I certainly would not have added that salt had I designed the system. The contract, then what you can do because of that is that if you destroy a contract, you can recreate it because in a later transaction you can call the constructor again with create to and resurrect the contract at the original location. And because when a contract comes into existence, that's actually interesting. I should check. Oh no, I'm pretty certain now. When a contract comes into existence, I'm very confident. I'm 100% sure. I'm very confident they call add balance. So when you give it the endowment, it's going to add that money to the money the contract already has. Actually, I'm very confident of that because there is a thing you can do where you can send money to a contract before it gets created. Actually, you know for sure. You can send money to a contract before it gets created and then create the contract and then start. And that's actually like a paradigm people will use for expensive multi-signatures is like, they'll like tell people, put money here. And then only once a bunch of money's there, they will instantiate the fact that was actually a multi-signature contract, like vault contract, and then start spending the money. So it sadly wouldn't actually fix the problem to have the semantics you would expect for self-destruct. So.
Well, it looks like the post condition of self-destruct. I mean, that creation logic is pretty weird already. Like to be able to send money to a non-existent contract and then recreate that. I mean, that's also just strange. But
there are a lot of weird things in the platform. Like, you can imagine a differently architected virtual machine in the first place that would have made these kinds of mistakes later less likely. One of the things, honestly, self-destruct as an instruction is just stupid anyway. There's a lot of people who were upset because, so here's the issue: it is typically the case that like it's very often in a lot of instruction architectures the case where if you have code that also has data in it because you've got arguments to instructions, and it's gonna be very difficult to tell the difference between code and data. So the question of can this contract theoretically self-destruct itself is almost unanswerable in most cases. Like you can, like there's a subset of cases where the code is sufficiently simplistic that you can trace through all possible execution paths of it and determine but it is possible to hide behaviors in a lot of contracts because the self-destruct instruction is just a byte of code that could be data in another context depending on what order of operations you jumped to it. And so
So you're trading now like the halting problem to is distracted. Is it distracted problem? Almost the same.
Yeah. And so then there's behavior that's really frustrating to a lot of people because it means that it means that you can't be for sure that this contract doesn't have some weird backdoor in it that will allow somebody else to later make it not even exist anymore. And between that, some of the semantic mistakes that it occurs, you can, so when I explained the implementation of create is that it takes as its argument the constructor code, and the constructor code returns the actual code. Create 2 takes as its argument the constructor code and hashes the constructor code. The constructor code could use state on the blockchain, like the current time, and in order to change its behavior. And so you could now make it so that on 1 minute it returns one type of code, and then you destroy the contract, and then later you resurrect the contract at the same address with different code because the hash of the constructor is the same, but the constructor's behavior was different because the time was different, which meant that it was able to return different code as the actual object. And so that's something that people find really freaky. Another issue with it is that when it gets around to deleting the objects, which it doesn't do at the end of the transaction, it does at the end of the block, there is a potentially arbitrarily large amount of work that has to get done. If that contract has existed for 3 years and people have been storing stuff in its storage state for the past 3 years, there might be gigabytes of data that you've got to find on disk in your database and delete. And so what is the cost of a self-destruct? It's very difficult to compute it. It's not actually the cost of the instruction does not take into account this arbitrary later at the end of the block amount of work that has to get done cost. And so people are concerned about about that. There's another issue. People are trying to make it to like the way that there were incentives for like cleaning up code and data, and so you'd actually get like a refund when you self-destructed contracts, and so they were changing the behavior there because like people were creating contracts at times of low gas cost and then destroying them at times of high gas cost when you would actually cause a lot of work to get done at a low fee because you get a refund for the cost of making the contract. And so there's so many mistakes with self-destruct. It's actually one of the pet peeves of Vitalik, who's the kind of the lead architect of the Ethereum project. And every time any opportunity comes up where there could possibly be a way of saying maybe self-destruct won't be a thing anymore, he brings it up and tries to push it. So there's been some discussion, which I don't think is a good idea, but there's been some discussion recently of this like Ethereum object format of making contracts have like a header and various other semantics. And it's like, well, maybe in an EOF contract, you cannot self-destruct. And then there was like account versioning, maybe in a V1 contract, how it's called self-destruct. Like they just kept bringing it up, trying to. So the fact that this instruction was the thing that caused Optimism all of his pain was just yet another like, oh, it's self-destruct again. Oh, of course, it's always self-destruct, always causing all the problems. So.
Oh, okay. Well, did you have a question? Nobody else has any other questions? Well, congratulations. And also, I mean, I think you made a significant contribution. I mean, Yeah, you collected bounty, but this sounds super serious. It's like I can't believe it. And you could like your exploit would have just you would just have drained the treasury.
Yeah, you could have drained the treasury. We still think though the max damage would be to not drain the treasury, but instead start buying up all of the rest of the tokens. It might have been even if they found it an hour later, even if everyone figured it out within an hour that you had an infinite amount of money and were buying everything, which might actually be the minimum amount of time. Like that might even be if there was a person who figured it out within 30 seconds and then like tried to tell other people, and though everyone started coordinating, it would probably take like an hour anyway in order to figure out what's going on and actually do something. And the by that time, I feel like you would have just scrambled the entire DeFi community sitting on Optimism to the point where you would have been unable to fix it. Like there's no money that you could have put into the system to compensate the parties correctly. I mean, you could compensate literally everybody who possibly had a claim, and you might be a lot more money than you never have expected. And it's just like the any that you possibly even the system that had in the first place. Like it would just be like a really really brutal bug. Um, so I got a lot of play on the like in the press on the narrative then on the white hat hacker angle, which is not something I'm used to. And I'm the gray hat hacker. Going in, being Robin Hood and messing with things. And they're occasionally, talk about various projects. I'd be like, I'd go for max damage on that one. Like, that ecosystem does not deserve to exist. But it's also usually in cases where I feel like no one's really going to get harmed other than the ecosystem will destroy. And here, this is one which is very clearly like these are people are going to get harmed by this, and they make a bunch of clean money. That's nice, I'm not a thief. I'm not gonna not a. There are some people out, some like friends of ours who were almost disappointed that I was like not a good thief. It was like, oh, come on, Jake. Shouldn't Jay have been able to steal $100 million or something? Like, he was an idiot for taking it too. It's like I would have not been able to steal $100 million. Not.
Who's paying you the 2 million? Yeah, the 100 came from Bob.
Yeah, the 2 million's from Optimism. So they're a project. They actually raised investment money in order to work on this optimistic roll-up tech, and they implemented this code and wrote the bug. And actually, funny story there is that so I work a lot with GeoHot. In the past, I've worked a lot with GeoHot. Even now, arguably, we didn't work together on much code. We did, but like typically he would work on a jailbreak and I would work on this the code that the like ecosystem the payloads that his code would load, and so we coordinated on it. GeoHot, the jailbreak community. GeoHot implemented the fraud prover for Optimism, and the story was that they were like trying to think what are they going to do. It's such a hard thing to build. They're not really certain how they're going to go about it, and they saw GeoHot at the coffee shop. They're like, wait, I admit that it's GeoHot. Maybe he knows. They went up and they talked to him, and GeoHot, mercenary often that he is, was certainly like, how much money you got? And, and so he went back to their office, and the story is that he spent a day staring at all their code, asking them questions. And then the next day, he stared at it some more and came up with a plan. And then he came back and he just typed it. And it was just like, it took him hours at that point to type it because he figured out what he needed to get done. And after just a few days of mostly staring, he built their fraud prover. And actually, I think in some ways, it caused some of their issue. Like the fraud prover that he had was a modified compiler that changed the behavior of a lot of the instructions by recompiling them to more complicated instruction sequences, which meant that it wasn't, by definition, as fraud prover could not be EVM compatible because it would require you recompiling all your contracts to different code, which would give you different hashes, which means that if nothing else, Crate 2 wouldn't work. And I rely on Crate 2 all the time. So but GeoHot's existence is also something that I don't usually explain. In my article, I don't explain this. I did say today that like I was expecting to get into an argument over the bug bounty, and there was no argument. And just immediately they were like, "Oh yeah, we will compensate you. We will accept this out of scope bug at the same level that we put, for all these other smart contract bugs. Let's talk about how to get this fixed correctly." And it's because when I reported the bug, the CEO of Optimism was in the car with GeoHot and gets the text message from the engineers I reported it to, saying that this guy named Jay has come out, Sorek on our Discord has just broken all of our stuff, and GeoHot was like, that guy was legit. I worked with him on the jailbreaking, and GeoHot also apparently talking with the Optimism people a lot about bug bounty programs when they were setting theirs up, and he had said, I don't really report things to bug bounties because they always some excuse for why they're not going to pay. It's out of scope. One of their engineers is already tinkering around with something similar. There's, there's it actually doesn't have the impact you think it does. We would have been able to notice it and mitigate it in time, and so he just doesn't do it anymore. So the Optimism people really took that to heart, and they were like, "We are not going to let that happen to people who report stuff to us." And then particularly when somebody who GeoHot then knew reported the bug, and they were like, "Okay, we have to pay. We actually have to pay." So the one kind of sad thing is that to the extent to which there are these big bounties and that might actually motivate people from like the iOS community and things to go and work on these issues, maybe you don't get paid. That said, I also think that there is an interesting mitigation to that, which is that so in this case, because it was so out of scope, I didn't talk to Immunify. I went directly to the Optimum people. But there is a lot of these bigger bounties are registered through external companies like Immunify or HackerOne, and Immunify and HackerOne do the triaging because you get a lot of false reports. A lot of people think there's a bug. There's not really a bug. And so they do a lot of the triaging. And then like Immunify, they get a cut of the bounty. That's their profit model. And so they're actually heavily incentivized to get you to pay. And then also their whole advertising model is we've got the biggest bug bounties in security. And that they and because they're in crypto as everyone else is doing web exploits and things, and it's like there's a $10 million payout available here, and they love advertising these things. So actually, we didn't even at this point technically didn't even pass through Immunify's hands, but it was an Immunify bounty. Immunify reached out to me. We're about to do like they haven't read the questions yet, but they finally got them. They want to do an interview with me for their website to talk about this big bounty that got paid out related to an Immunify exploit. So I think that actually also can help mitigate the issue of like you don't really get paid.
Wow, what a story, Jay. You were just sitting here, and then fast forward a few weeks, here we are with the talk. Thanks for.
Yeah, that's cool. It feels like a mini TED Talk.
Yeah, the whole process is also interesting.
A lot of the time was honestly spent doing the write-up, and I was coordinating with them constantly, concerned that they understood that like the write-up was very important to me. That I didn't want like Optimism like doing a low quality post-mortem write-up or something that it's like I'm doing this great write-up. It's just this, and they actually didn't see it until like hours before we published it. It was less than a day, but it was more than just hours, but still measured in hours of publishing. And they were like, oh, this is, so I mean, I spent so long really perfecting that article, and I got a lot of feedback from people like Britta from the still from the person who's doing community management of the jailbreaking system and CCS lit student and everything. It was just really helping with a lot of stuff. Dan Montgomery and Conrad, who's not from CCS, but he was providing me a lot of good feedback. And so the Conrad Kramer is just somebody from the iOS jailbreak community, worked for Apple for a while. But yeah, and then it was always kind of weird though, because then I went to the conference, and the conference. So actually, I had submitted a talk to the conference. I came up with I got inspired to actually do a talk at a crypto conference on December 23rd. And I had this amazing talk finally that came to me. It was this talk about multi-chain deployment issues using Create 2 and the compliance problems of different blockchains. And I I put together the abstract for it on Christmas Eve, and Travis was so excited that I was going to, and I was going to actually go to a crypto conference. Travis, CCS computer science student who's been our marketing person that worked it for a while. Very excited that we're finally going to get the hit of technology to actually go talk at a conference on crypto about stuff that we're doing. And I go and I look into the applications for it, and it says that you really should apply by December 15th. Like you're probably we're probably not able to read your thing if you apply after December 15th. And I was just like, I'm not gonna. It's not gonna. But also freeing. It's like, well, I'm not gonna get. I'm not gonna get it anyway. And so, but then also it was a little bit awkward. I started the process and asked me some questions, and I was like, I need to do a good abstract for. I need to do a good. So I didn't apply until January 2nd. No, like really being confident that I wasn't going to get it. And then I finally applied. It asks me questions. Ask me questions. How long is your talk? 5 minutes, 15 minutes, 20 minutes, 5 minutes, 10 minutes, 15 minutes, 20 minutes, or other. I select other and I type in 40 minutes. And I'm even like, this is a talk that I would spend. But they seem to want short talks. And I think that I can do a 40-minute version of this. And I submit that. And I submit the abstract and answer all the questions. And then I surprisingly, like a week or two later, I get back, you're in. Like, wow, I got accepted. And then a week passes and I get an email saying, we've scheduled you for 20 minutes. And I'm like, I can't do this talk in 20 minutes. Like I was so cool with not getting the talk. I mean, I was assuming that they weren't even going to read my application because I sent it in 3 weeks late in the wrong year, right? And then they accepted me and scheduled me for 20 minutes. And then I got into this massive back and forth argument at the conference that just kept escalating as I by the end, I got a little cynical, but I was kind of a humorous level cynical. Like I think it was the kind of version where somebody was kind of realizing that, like, where this had gotten to would laugh with me. And like I was like winky facing with the tongue in the places where I was doing it. And they got really angry at the fact that I kept pointing out this. And I wasn't trying to get 40 minutes. I was just trying to be like, can I give a different talk? And I came up with a different talk. My different talk is I was going to work on just the compliance issues between chains. I've been working on some tooling for a better block explorer that would allow me to look at individual state-by-state modifications to the chain. And I was going to just finish the synchronization of that and get working on a chain, and then I'd maybe do a demo of it. Because a lot of the talks are honest. The 20-minute talks are mostly, we developed this product. Here's how to use it. Like I can do one of those 20 minutes. Here's my block explorer. Here's how to use it. I normally try to do insightful talks, but that's, what's the point now? And so, but in the process of getting that and frantically trying to get the scheme for it right, I found the bug in Optimism, because Optimism was always the chain that was causing the most issues. And I would keep going back and testing, and I would be like, state by state, I don't really understand the self-destruct semantics. I want to know exactly at what moment does the contract go away? And what moment does this field change? And I started adding logging expressions to everything. And I was reading to the code, and I was like, this doesn't make any sense. There's no way this could work correctly. I bet, how does Optimism work? And I look at Optimism. Optimism just doesn't work. And so it was kind of how I found the bug, was the failed talk submission.
Well, I think it's great that
which actually, there's one more part of it, which then made the conference organizers a little bit more happy with me, I'm sure, as I went back and forth with them on my redacted talk abstract of, here, now can you put this abstract in? Now that we've agreed that I can have a different abstract, can you put this one in? It doesn't have any proper nouns in it. They've all been redacted. And then can we change the title of the talk after we're done with the disclosure? I cause all sorts of problems.
That's good. That's what Jay does. That's awesome. Yeah. And also I really like that this was like, the approach was just analytical. You just read code, and such few lines of code. It's ridiculous. And even the exploit it really is surprising.
Most of the exploits of these logic ones, that's what makes the hack talk so great, right? Is that the code that the bugs are in are all really easy. And a lot of times the exploit is something you can just kind of off the cuff of, explain, like, here's the exploit. You start getting the complicated ones, and it starts to, like, you start to feel like, oh yeah, sometimes it can actually be hard to exploit these things. But like, there's the one where it was just open your type telnet and hit enter. Oh, that was the exploit. So,
Okay, Jay, I think we want to give you an applause here. Yes. Yay, Jay.
Yay,
Go,
Jay.
Jay. So anything else? Any remarks other than just thanking Jay and yeah, it's been memorable. This doesn't happen every time we teach this class. That there's a Ethereum.
no, it's like every year, Murat, there's a $2 million bug bounty at least, right? I mean, remember last year?
There's always something
It's
interesting.
always the same company too, so they're just paying him a salary at this point.
Maybe he just uses the bug to add in the $2 million on.
But also, I mean, like, what's really also hilarious is how like the talk, like we can actually understand your talk, and that's sort of built up. Like it's almost like a thriller-esque, a crescendo to this moment that now we can actually understand some of the stuff we were talking about, even relating to the object-oriented design and what not to do, and data isolation or firewalling data. The state of an object should be really, how do you protect it? Like we've been talking about this kind of stuff. Just the last couple of lectures.
Yep. I was really especially enjoyed your earlier talk too on like kind of all the major like vulnerabilities you were touching upon in the past. Like
The bag of hacks, yeah.
Yeah, it was like really eye-opening and kind of learning about
Oh,
what
yeah.
was really going on
Yeah,
there. Not just like all of like the stuff going around in the media, but now it's like, well, like here's actually the programming mistakes or how somebody might have thought about this, or maybe how it even happened in the system. Maybe it wasn't even a mistake, it was the way the system was designed. That thing about like the Unix, I forgot exactly which one it was, but I love that story. Yeah.
Yes, Jay.
Well, thanks for actually letting me give my talk. I didn't actually give my talk.
Is this the first time you actually successfully delivered this talk?
This talk, yeah. I mean, it was just 2 weeks ago.
That should be stated. We should actually.
Yeah, we should have recorded it. That's my fault. I forgot to.
Maybe Jay did.
I did record mine. I didn't record the Zoom. I recorded the my image. So yeah.
Okay, that's great. Share it with us.
Awesome. Thank you.
Thank you, Jay.